What's next?
I stopped.
So you're watching now? Amazing. Okay.
Which screen do you want to look for?
We can put some lights to get some light.
Sorry, that's not.
Oh, please leave the right screen. That's a good job.
Frank, you know.
Yeah, I know.
Okay. Now everyone knows what's bothering me in this slide at the moment. That needs to. Oh yes, it's the. I don't want to try. It doesn't work on this screen. Okay, so someone look up to. It doesn't work on this screen. It works on. I think I need to switch to this place. I need to switch place. Okay, so. Connecting over. Right, so we've been working on the Space Mission Roadmap Challenge, and very creative is I just follow what's next. And the link is working, and the interface of our product is displayed on that screen. But however, before going into the actual product that we've created, I want to start from the distance and gently get to what we've been working on. So, as a society, we've been wondering what's out there. Too much. What's out there? Can't go wrong with the kitten. What's out there beyond the Earth's atmosphere, and what is like there, and what it's like to be there. Some people gave more thought to that than other people. This is Konstantin Tsiolkovsky, which is he's a Russian scientist and one of the fathers of astronautics and the rocket science. And he's been wondering about what it's like to be in space, what science to be in space, and he was doing all those predictions of what it would be like in here to move in space. So basically, he summarized it in saying that Earth is a cradle of humanity, where every child needs to leave this cradle at some point, and that was the drive of his career. And the science he envisaged at that point that was required was of a grand scale. And we know that the science has been moving to the stage where we're getting closer and closer to actually putting a man somewhere further away than the other planet. And just to emphasize how drastically the science changed over time, since the first time we had we started to have spacecrafts researching space. Just have a look at the images. This is the very first image ever that we have of Mars. It was taken by Mariner 4, and it was absolutely groundbreaking at that point. It was 1963, 1960s. So the next image is from the Spirit rover in 2003. This is the very first colored picture of Mars that we have. This is how the technology is changing. And the last one is the very first selfie taken on Mars. And so now we gently get into the actual challenge that we're working on. So with all these technologies that we're developing, as we had trial missions, failed missions, successful missions, and all the data that we were collecting that went from barely realizing what the surface is looking like to actually having very high definition pictures. And we have all those missions and all that information about all the different missions, not just Mars. We picked Mars because it's obviously topical and most interesting. But all those missions, the data all over the internet is very scattered, and it just basically had to be very interesting to piece the data together to see what actually was going on. And the challenge, the brief of the challenge was to to combine all the data and bring in one place with data visualization. So that's what we've been working on. So our idea was to create a first stop resource for all of the spacecraft missions, for space explorations, for other planets and other space bodies, not just planets. That's what we've been working on for 2 days. And the most interesting, to go back to the Tsiolkovsky, to see how the technologies were evolving and how close we are to having enough technological gear to actually have a manned missions. Aside from that, we were working on the technology tree. And the technological aspect, I'm going to hand over.
Right, so there were 6 of us, broadly working in 3 groups. We had a bit of web development, so we'll go through web interface in a minute. We had a set of data management tools for the data set, and we had 2 people doing research. So we've actually constructed a curated data set. We've gone out to the internet, we found a lot of different resources, and those have been pulled together. So we've got data management tools to help curate that, to add, edit, and then that is then getting processed into a web accessible format. So we'll go through the website first. So this is all JavaScript HTML5. So we've got a really simple layout to start with. So you've got a bit of a solar system map, roughly scale. Highlighting over each of the planets gives you a little bit of information, number of successful missions, number of failed missions. Clicking on a planet will bring up a timeline of successful missions, and then you can click through onto individual missions, and that will bring up a little bit of headline information, some key images, some key facts. And this is all being pulled out of data sets. This is just one possible visualization of that data set. And then over the map of the solar system, what we're trying to do is build a very simple graphical visualization of flight paths. And obviously, in real life flight paths, you've got satellites moving, you've got planets moving. It's very difficult if you aren't familiar with that sort of that type of model to get your head around the exact paths spacecraft are taking. So we've just done really cut down visualization, sort of A to B flybys, and just try and capture the essence of the path. Mariner 4 went off to Mars, flew out and back, and then disappeared. Mariner 7, I think it was. Again, fell short. It was only intended to study space in between, so again, we just tried to capture the essence of what that was. So that's the web visualization in brief. Shuffle on. So going forward, where we're looking at moving, this is an extended example of sort of trajectories. This was the Cassini probe. So in reality, it did several flybys, and if you look at it on a map, it's orbiting the Sun, it's going past Venus, it's going past the Earth. It's a bit difficult to get your head around. So we're just trying to cut it down, grab the essence of what perhaps a flyby might look like. So going forwards, perhaps extending this is the sort of visualization method is one we would look to go down. So yeah, data set. So the data set is it's been curated. It's very minimalist at the moment, so only looking at the Mars missions, but it's all pulled together into a web accessible format. This is all in JSON. It's keyworded, so this is accessible, anyone can go and get hold of this, pull it down, do their own visualizations. We thought it was quite important because it's only a 2-day exercise. Actually, I think the main value we can get out of this is actually starting the construction of this data set as opposed to the specific visualization we decide to put on top of it. As I say, we've got tools to actually help curate this going forward, and so going forward we'd actually look at expanding that bit a bit more, visualization sort of sat on top. And then sort of we can sort of bring other bits and pieces into the visualization, so looking at bringing in perhaps sort of lander profiles, so looking at descent paths, that sort of thing. Anything else on that? Patrick?
So this is, we think, the most interesting part that we obviously didn't have time to do the way we would envisage it. But this is the technology tree that basically shows how every single mission with the events that were happening for the first time, the first good quality chemical analysis, the first successful landing without any assistance of the having a lander and the rover in a separate unit. All of those bringing us closer to the man-Mars base, and we highlighted all the key technological aspects that would require to be addressed for that to happen. And we want to look at all of the missions that were done in the past, that are happening at the moment, and that are planned for the foreseeable future, to see what's been addressed, and what else needs to be addressed for the Mars base to happen. And the audience that we think this would be interesting to basically everyone who's interested in space, because at the moment all the information is very crude form on NASA and the Jet Propulsion Lab websites in a very old style formatting, and it doesn't bring everything together. It's very fragmented, and this is the mission, that's what's been done, and it doesn't fit into the bigger picture unless you start working on something like this. And this is the next step that we're going to be working on next. After finish my duty.
What's the frequency you would expect people to use it if they're interested in it?
Well, as soon as we repopulate all the sites, all the missions, basically we want it to be frequently updated. So we're going to try and pull in the news feeds into what's going on. So basically, with that being in place, we're hoping that will be, and that being envisaged as the first point resource quite frequently. So we want to inbuild tools that would facilitate that. Make it.
I was just wondering how much data actually comes through about the missions and how frequently.
Oh, there's a lot, like obviously Curiosity every day comes out. We still have the twin mission, Spirit and Opportunity. That was quite interesting. There were the second rows, the two twin machines. The Spirit operates for a couple of years and then lost contact with Earth. But the Opportunity has been going on for now it's over 10 years, collecting the data with weekly updates. But they're buried somewhere in NASA website. So that's happening.
Yeah.
And we still have orbiters collecting the data, basically facilitating the data between the rovers.
So not just for Curiosity, but any of the satellites that are out there submitting further data.
Yeah, it's still going on, and obviously it's not just the Mars has been the most interesting one that's probably focused on it, but there are other missions that they're
Say that you've got Cassini around Saturn, the stream of incredibly gorgeous photos coming out every week. But yeah, I mean, it's obviously for those ongoing missions, and of which there are quite a few, and we kind of focused on the planets here, but obviously you've got things like the Rosetta spacecraft going off to do comets, you've got things en route to asteroids. There's a lot of ongoing missions that people aren't necessarily aware of, apart from when they pop up in the news because there's a major event, but there's still valuable data coming out all the time, so that would be where we're trying to transport the data in.
I have a question. Have you considered education as a possible sort of target audience? In the sense that probably also at various levels.
Yeah, I mean, so certainly in the visualization, obviously we've tried to give this very simple visualization of flight paths, and the actual header information is fairly stripped down in this. So this specific visualization is targeted at people who perhaps accessing it for the first time, don't particularly know a lot about the missions. So I think that would be a sort of education, in learning, and sort of Sasha and George doing a lot of the research, and there's all the stuff that's in here is all learned for the first time. So that's kind of where we're focused at the moment. I think going forward, whilst we probably keep that, actually the in-depth data tools, adding in the sort of the expert side of it would be key to actually making it a sort of valuable resource for everyone.